So this is circuit 1 triple I. It's basically the same circuit as 1 double I, but with the resistor, with the 2K resistor and the LDR flipped. And we're still using 9 volts as our power supply. The circuit is on. And when I cover the LDI with my finger, the LED turns off. So basically, the results that we're expecting, it's basically the opposite. So when the LDR is in dark conditions, the LED turns off, and when it senses light, the LED, turns on. So the reason for this is that in light conditions, the LDR has a resistance that's less than the 2K ohm resistance, in which the 2K ohm holds most of the voltage, which goes over the turn on voltage of the transistor, which turns the LED on when the LDR experiences light condition. But then when the LDR is covered, then its resistance increases, in which the voltage increases, which causes the 2K ohm resistor's voltage to decrease to a voltage lower than the turn on voltage, which turns the transistor off, hence turning the LED off. Yep. So here we have the PNP configuration. Right now the circuit is off. So it's the same configuration, the same circuit, sorry, but with the polarity switched, the LED polarity switched as well. So the circuit is on. So right now the LDR is sensing light, in which its resistance decreases, in which its voltage decreases as well, causing the 2K resistor to have all the voltage, in which turns on the transistor, turning the LED on. And when I cover the LDR, its resistance increases, causing its voltage to also increase, causing the 2K 2K resistor's voltage to decrease to a voltage lower than the turn on voltage, turning the transistor off, hence turning the LED off. Pretty cool. It works the opposite way.